Well, here comes Bukang. Let's just quickly recap what we said yesterday. We said the parallelogram is the normal GP. Ne? That means that all the doctors who specialized had to be a GP before they could specialize. So the parallelogram, the rhombus, the rectangle and the square, they are all parallelograms. But the parallelogram is not a rhombus, and the parallelogram is not a square, and the parallelogram is not a rectangle. Alright. So we saw something new that we probably heard of but didn't really use as much with a parallelogram is that the diagonals bisect each other. Very important. And we saw how to prove that yesterday. When you prove the midpoints of the two diagonals are the same, then you've proven they bisect each other. Next, we looked at the rhombus. Oh, we didn't even write rhombus here. Right, with the rhombus is a parallelogram where not just the opposite sides are equal, also the adjacent sides are equal. That's the one that we know, or that's the most familiar with all of us. We know it well. But the one that we didn't really use as much in previous years, and that you must know, is that the diagonals, they don't only bisect each other, they are also perpendicular to each other. So you can imagine we would use something like the gradients of the lines. Ne? If the product of the gradients is equal to -1, then it means lines are perpendicular. Ne? So that might be a way to prove that it's a rhombus when you prove that the diagonals are perpendicular. So proving that the diagonals bisect, if you want to prove that it's a rhombus, is not enough. You won't get any marks. If you prove that the diagonals bisect, you have proven it's a parallelogram. And the question will state, prove that it's a rhombus. Okay, next up is the rectangle. Okay, a rectangle, right, like the parallelogram, has got two pairs of opposite sides equal and two pairs of opposite sides parallel. It's got diagonals that bisect each other. And it's also got these vertically opposite angles that are equal. Okay, now the thing that's different, that you know, the familiar one, is that the angles of the rectangle is 90 degrees. So that's one way of proving that the parallelogram is a rectangle. But you guys know we're not working with angles a lot, ne? We can maybe prove that those two are perpendicular with their gradients. But the other way, the new one that you maybe haven't used as much, is that the diagonals are equal. So remember, with the parallelogram and the rhombus, they only bisect each other. The left side and the right side are equal, and the top and the bottom is equal. But with the rectangle, this whole line, let's just call it A, B, C, and D. AD is equal to BC. The whole diagonal is equal. Okay, the last doctor we have is the most specialized doctor that there is. It's the neurosurgeon. I think that's like a very good doctor. Very specialized. Okay. So when we look at the square, the same as with the parallelogram, it's got two pairs of opposite sides equal. But like the rhombus, they are all equal to each other. The adjacent and the opposite angles are equal. Then it also has two pairs of parallel opposite sides parallel to each other. It's got the diagonals that bisect each other. And just like the square, like the rectangle, they are all equal to each other. And just like the rectangle and the parallelogram and the rhombus, the opposite angles are equal. But like the rectangle, the adjacent angles also, and they're all equal to 90 degrees. But that's also a familiar one. You guys know that. And then, just like the rhombus, the diagonals are perpendicular to each other. So if the question asks you to prove that this quadrilateral is a square, if you prove that the angles are 90 degrees only, you have only proven a rectangle. Do you understand? If you prove that the adjacent sides are equal, if you only prove that, you've only proven that it's a rhombus. You haven't proven that it's a square. If you only prove that the diagonals are perpendicular, you've only proven a rhombus, once again, not a square. So because the square's got all of the properties together in one, you're always going to have to prove two. You're always going to have to say, okay, all the sides are equal, and then it's a rhombus, but what's the difference between a rhombus and a square? At the square, these angles are 90 degrees as well. So you mustn't just know the properties of the quadrilaterals, you must also know the differences between them. What's different between a square and a rhombus? What's different between a square and a rectangle? And so forth. Do you understand? Okay. I'm quickly going to hand out the papers to you. Oh no, we still have to do the kite. Please write kite. Okay, if we look at the kite, we see that these two sides are equal. Two pairs of adjacent sides equal. So do you agree a square can also be a kite? And a rhombus can also be a kite? Okay. But the kite doesn't necessarily have to be a rhombus or a square. The other thing is that the diagonals are perpendicular to each other. And then only one of the diagonals bisect the other. We also know that this whole angle is equal to that whole angle. This angle at the bottom is being bisected. This angle at the top is being bisected. Are you done? Okay, the last one that we're going to look at is the trapezium. Okay, but it only has one property, and that's one pair of opposite sides parallel. Not equal, parallel. Go. So I just want us to draw it as well, so that you have everything. Now, I draw it here, but you will go on at the bottom. Then those of you still busy can just keep copying. One pair opposite sides parallel. That's it. someone help me, please? Because they don't staple this, and I can staple, you can start adding up. Okay. This is also a summary. I gave you ones like these for the first term as well. Do you remember? You probably put it in a file and didn't use it if I look at your marks, no? No, I'm kidding. Okay, grappie. Right. So here's also a summary and a flashback, straight line equation, gradient formula, parallel gradients, everything on there. We've spoken about all of it. And then they show you some examples. They're going through it. Not going to pay a lot of attention to it. I want you to open at Eastern Cape November, Mathematics, paper 2. Yes, it's question 3. Okay, I'm going to guide you in doing this. I'm going to give you clues, but then I want you to do it yourself. Okay, so have your pencil ready so you can make some notes for yourself. So they say in the diagram below, line AB makes an angle beta. What type of angle is that? Inclination angle, do you see? Because it's the angle that the line makes from a horizontal straight line. Okay. The line CD makes an angle alpha. What type of angle? Inclination. But you see, this is acute, this is obtuse. No? You remember you're going to get a negative gradient somewhere. Then you ignore the negative, then the answer you get, you subtract from 180. So this one's going to be 180 minus, and this one you're just going to use as it is. A and D are points on the x-axis. The coordinates of B, so this one here, is root 3. That means from here to here is root 3. And T. So we don't know the length T. Okay? AB and CD intersect at E, a point on the y-axis, and then AED is 63.69 degrees. Alright, so what I just quickly, they also give us the equation of CD. We will look at it now. Can you quickly tell me, looking at the angles, at alpha, beta, and 63.69, do you see some sort of relationship between those three angles? Just take a look and then you can put up your hand if you think you have it. Leokwe? Alpha. Are you saying alpha? Okay. Listen to what she says. She says that alpha here is the exterior angle, and remember when the exterior angle, when you have an exterior angle, it will be equal to the sum of the opposite interior angles. So you've got one of the interior angles. If there's any way that you can either get alpha or you can get beta, then you can find the other one. Do you agree with me? Okay. That's the first thing I want to tell you. Then I want you to look at the equation of CD. There is something wrong with it. Can you tell me what is wrong with it? What? What's wrong with that equation? Do you like it the way it looks? It's not in standard form. And when it's not in standard form, I can't use any of the knowledge I have. Remember, usually we know that the number in front of the x, the coefficient in front of x is the gradient. Do you remember that? But the gradient's not 3. Because I can even see that. You see CD is a negative line. It can't be 3. It's because this one is not in standard form. So I would start right now by shuffling this thing. So that it's in standard form. Do you see I've got the gradient of CD now? What's the gradient? What's the gradient of line CD? There's no calculation. What's the gradient of line CD? This is the equation of CD. Negative 3 over 2. Why is it only Temba that can say that? Do you guys not know that? Because you need to tell me if you don't know that, because then we need to go back. Do you know that? So why aren't you saying it? That is the gradient of the line. And once you have the gradient of the line, you can calculate the inclination angle. This is M. And tan theta, I'm using theta, in this case it's actually alpha, is equal to M. Do you see it, grade 11? Yes. Okay. The first question, 3.1. They ask you to calculate the coordinates of E. This is E. Who has a plan for me or can tell me what the coordinates of E is? Katleo? Moana? There's nowhere where they've told you that it's a midpoint. Okay? So if they don't tell you it's a midpoint, you can't use it. Zero? Are you saying the gradient is 0,3? The E is 0,3, or are you saying it's 0 and 3? Is that what you're saying? You are correct. Can you please tell me why? Very good. Well done. E is the y-intercept. Can you see that? It cuts the y-axis there. So what he's saying is, when it cuts, the line cuts the y-axis, the x is 0. You see, it didn't move left or right. And to know what the y value is, that part, you read it from the equation. So that is the point 0 and 3. Do you understand that? You're not just going to write these answers down like I'm doing it now. You're going to do the things. You're going to write this equation, get it into standard form, do the work. You hear me? In your books, not on this page. Right, determine the gradient of CD. We already did that. The moment we got it into standard form, we had the gradient of CD. Next, calculate the value of alpha. I already told you, tan of alpha is equal to the gradient, and you've got the gradient. So it's shift tan gradient. We'll be able to do that. Then the next one, hence determine the value of beta. Leak we told us how, ne? Exterior angle equal to the sum of the opposite interior angles. Determine the equation of AB in the form y equal to mx plus c. Okay, I'm going to help you with this one. At 3.4 we're calculating beta, do you agree? Now, if I look at the line AB, the tan of beta will give me the gradient. And I just calculated beta at the previous one. So if, let's say that beta was 30 degrees, then all you do is tan 30 and it gives you the gradient. Does that make sense? Okay. Then you can substitute into m because you've calculated it with the inclination. Now you just need another coordinate, the x and the y, to put into, or to be able to calculate c. Now I have a coordinate b, but it doesn't have an x and a y. It only has the x. But do you remember Temba just told us what e is? And e is also a coordinate. So I can put in 0 and 3 in the place of x and y and then solve for c. Okay. Now they want you to calculate the value of t. You've got that equation. That point lies on this straight line. When you've got the equation, you just put in the x value to get the y value. Do you remember that from grade 10? Not? Yes, yes, okay. And then they want you to calculate the area of triangle A, B, D. Okay, so what I would do, I'd get that value, the x-intercept. I'd get that value, the x-intercept. No? Because if that is, for instance, -2 and that is 3, then what's the length of this? It's 5. No? And we know this length is 3. And how do you calculate the area of a triangle? Half times base times perpendicular height. The base is 5. The perpendicular height is 3. And you say times a half. This is not -2 and 3. I don't know what it is. Okay? You're going to have to go and calculate it. I'm just showing you if you got the answer. Alright. So, now in class time, I want you to do that question 3. I'm going to close it now. No more looking. Now you tried. I'm here to help you. Remember what I said yesterday, eh? You have to struggle a bit with this so that you can start getting the skills. That's why I only help you a little bit.